Now we're going to see how to represent the experimental data in a way that makes the analysis and interpretation of the data much easier. It's called the graph. In a graph, we plot two sets of data corresponding to two different quantities or variables known as the independent variable and dependent variable. The independent variable is the variable that we control, which is generally plotted along the x-axis. The dependent variable is the variable that depends on the choice of the independent variable, which we cannot directly control. For example, if we drop an object and measure the time it takes to hit the floor, the height of the fall is the independent variable, since we are choosing it prior to the experiment. The time of the fall is the dependent variable, since it depends on what height the object is falling from. While performing the experiment several times and dropping the object from different heights, you should record data in the table as shown on the screen. In order to understand how the time of fall depends on the height of fall, we will draw a graph where height h will be plotted along the x-axis and time t will be plotted along the y-axis. This is what a hand-drawn graph may look like. When drawing graphs, you should pay attention to the following. Draw a large graph and utilize as much space as possible. Drawing bigger graphs makes them easy to read and results in less errors. Label the axis clearly with the quantity being plotted and its units. Choose a proper scale. In this case, it is sufficient if we plot from 1 meter up to 2 meters along the x-axis, and from 0 second to 1 second along the y-axis, since all the data points lie between that range. Once all the points are plotted, join them using a smooth line or a curve. Do not draw lines from point to point. Remember, not all graphs are linear. For example, this one is not. Do not force a straight line through the points.